we're going to be looking at why all of the angles in a regular polygon must be the same. I assume you already know what the regular polygon is, but for the sake of understanding this proof, I'm going to emphasize two very specific properties. The first property is the one that everyone knows. That is that the regular polygon is equilateral, meaning all of the sides of the polygon are exactly the same length. But the other property is one I think is less well known, and that is that in a regular polygon, every vertex lies on the edge of a common circle. By a vertex, we mean any of the corners of the polygon. And what the second property means is that if you have a circle of a specific size and you place a regular polygon inside that circle, each corner will lie on the edge of the circle. We can see this is true if we just look at a few examples. We've got these three regular polygons, the pentagon, the square, and an equilateral triangle. And if I place them in circles of a specific size, you can clearly see that each corner or vertex of each of the regular polygons lie on the edge of the circle that they're sitting in. In fact, any polygon that has this property where each vertex lies on the edge of a common circle is called a cyclic polygon. But these specific ones have their own property because each edge of the polygon is of equal length. And for that reason, regular polygons are cyclic. Now, I've highlighted these two properties because I'm going to use the two of them to prove that all angles in a regular polygon are equivalent. So let's begin. We'll start with a circle, and the green dot is the circle's center. And let's drop in an equilateral triangle. Then let's highlight each vertex of the triangle. Now, because all of these edges are of equal length, the distance between any two adjacent points must be the same, because two adjacent points are just either end of an edge of the polygon. So if we hide the shape now, we know that for any 2 points on the circle, the distance between them must be the same. Now, because all of these 3 points are on the circle's edge, their distance to the center of the circle must be the same, because the distance from the edge of a circle to the center of the circle is the radius. So now if I draw a line between each point on the circle to the circle center, these 3 lines must be of equal length. Now let's take any 2 adjacent points and join them with a line. By joining the left and right points, we've created a triangle. But the left and right edges of this triangle must be of the same length because they are the length of the radius. And we know that a triangle that has 2 equal edges is an isosceles triangle. So this triangle is isosceles, and in an isosceles triangle, the base angles are of equal value. Let's give those base angles the value of A. Now let's join another 2 adjacent points. We'll join the point on the right to the point on the top. This forms another triangle. Now if we examine the 2 shorter edges of this new triangle, we can see that again those 2 edges must be the same length because they are just the length of the radius of the circle. So this is also an isosceles triangle, and therefore its base angles must be equivalent. But before we mark those angles, notice that for both triangles, the length of the base is just the distance between 2 adjacent points on the circle's edge. We showed earlier that that length is always the same, because that is just the length of the equivalent sides of the regular polygon. So the bases of both of these triangles are of equal length, and the other 2 edges of each triangle is just the length of the radius, which means that both triangles have the same base and the same non-base edges. So both triangles have corresponding edges of the same length, which means these 2 triangles are congruent. So the base angles in the second triangle must be the same as the base angles in the first triangle. And so both base angles of this new triangle must have the value of A. Now if we join the last 2 adjacent points, now it should be obvious that we've ended up with the same scenario as before. A new triangle has been created. 2 of its edges are of equal length because they are the length of the radius, and the base of this new triangle is just the distance between 2 adjacent points on the circle. So the length of this base must be the same length as the bases of the other 2 triangles, and its non-base edges must be the same length as the non-base edges of both of the other triangles, and so it must be congruent to the other 2 triangles, and therefore it must have the same base angles. And hopefully now you can see that we recreated the equilateral triangle, which is a cyclic polygon, and that each angle in the polygon has the same value. And that's because each angle is made up of two adjacent base angles of the triangles we formed earlier that are congruent. We've just got one more step, and that is to explain why what is true for the equilateral triangle must be true for all other regular polygons. I'm going to summarize what we just did with the equilateral triangle with two other regular polygons. We have a pentagon and a hexagon, and if we place them both inside a circle, it's clear that for each shape, each vertex lies on the circle's edge. We can view each vertex as a point on the circle's edge. Let's highlight those. Because any two adjacent points are just either side of the polygon's edge, and the edges of each polygon are all the same length, the distance between any two adjacent points must be exactly the same. And that has to be true for any regular polygon. Now the distance from each point to the circle center must be exactly the same. If we join each point to the circle center, we end up with several inner triangles for each polygon. The base of each of these triangles is just the polygon's edge, so all the bases must be the same. The non-base sides of each triangle are just the circle's radius, which means two things. It means that all of the triangles have the same edges, and therefore they are congruent triangles. And because two edges of each of the triangles is the length of a radius, they're the same length, and therefore the base angles of each triangle must be the same. And all of the triangles, being congruent, must have those same base angles. And finally, each angle in the polygon is made up of two of those angles. And because all of the angles are the same, each angle in the polygon must be the same as all the other angles. This will apply for all regular polygons because they are equilateral and are cyclic. So that's how we know that all of the angles in a regular polygon are equal. Well, that's it for now. Thanks for watching.